Okay, so in this lecture I'm going to be going over a circuit problem, and that circuit problem is to find the node voltages and the power of each voltage source of this particular circuit. So I have here VA, VB, and VC at these nodes here. Okay, and I have two voltage sources in this circuit, one here, 12 volts, and then another here, 4 volts. So again, the problem is to find the node voltages and the power of each voltage source of this circuit. Okay, so first at VB we have 12 volts. That's constrained, and that becomes equation 1 because as you can see here, at node VB you have 12 volts across it, right? From there to ground. Okay, so that's constrained. So VB automatically equals 12 volts. So next, KCL at node VA. So we have VA over 3 plus VA minus VB over 18 plus VA minus VC over 8 equals 0. Then next we have VA over 3 plus VA over 18 plus VA over 8 minus VB over 18 minus VC over 8 equals 0. And then next we have 37 VA over 72 minus VB over 18 minus VC over 8 equals 0, and that's going to be equation number 2. Next we are going to take equation 1 and put it into equation 2, and we have 37 VA over 72 minus 12 over 18 minus VC over 8 equals 0. And so next we have 37 VA over 72 minus VC over 8 equals 2 over 3. That's equation number 3. Next, KCL at VC. We have VC minus VA over 8 plus VC minus VB over 5 plus VC minus 4 over 6 equals 0. And then next we have negative VA over 8 minus VB over 5 plus VC over 8 plus VC over 5 plus VC over 6 equals 2 over 3. Next we have negative VA over 8 minus VB over 5 plus 59 VC over 120 equals 2 over 3. That's equation number 4. Next we're going to take equation 1 and put it into equation 4. And what we have here next is negative VA over 8 minus 12 over 5 plus 59 VC over 120 equals 2 over 3. Then next we have negative VA over 8 plus 59 VC over 120 equals 46 over 15. That is our equation number 5. And so we have two equations and two unknowns. And so using equation 3 and equation 5, the system is A matrix equals 37 over 72, negative 1 over 8, negative 1 over 8, 59 over 120. Vector B is equal to 2 over 3, 46 over 15. And vector V equals VA and VC. So VA and VC are our unknowns. And so when we compute V equals A inverse times B, we come up with a final result for an answer for the node voltages, and VA is equal to 3, VB is equal to 12 as previously stated, and VC is equal to 7. So next, the power of the 4-volt voltage source. So the currents at VC are going to be I of the 5 ohm plus I 8 ohm plus I 4 volt equals 0. And so we have VC minus VB over 5 plus VC minus VA over 8 plus I 4V equals 0. And then next we have 7 minus 12 over 5 plus 7 minus 3 over 8 plus I 4V equals 0. Then we have negative 1 plus half plus I 4V equals 0. And then we have negative half plus I 4V equals 0. And then finally I 4V equals half. This current is positive, so it confirms that it leaves node VC. This means it goes into the positive terminal of the 4-volt source. So the source is absorbing power and has a positive sign. So P4V equals plus I4V, V4V, which equals positive half times 4, which gives us a positive 2 watts. So next, currents at VB. I of 5 ohm plus I of 18 ohm plus I of 10 ohm plus I of 12 volt equals 0. And so next we have VB minus VC over 5 plus VB minus VA over 18 plus VB over 10 plus I of 12 volt equals 0. Next we have 12 minus 7 over 5 plus 12 minus 3 over 18 plus 12 over 10 plus I12V equals 0. And so 1 plus 1 over 2 plus 6 over 5 plus I12V equals 0. And then next we have 27 over 10 plus I12V equals 0. And then finally we have I12V equals negative 27 over 10, which equals negative 2.7. This current is negative, meaning that it enters node VB. This means that it comes out of the positive terminal of the 12-volt source. So the source is delivering power and has a negative sign. P12V equals negative I12V, V12V, which equals negative 2.7 times 12, which equals negative 32.4 watts. With the simulation results here, you can confirm those values that we just solved for. And so we have power of the 12-volt source is negative 32.4 watts. Power of the 4-volt source is 2 watts. VA is 3 volts. VB is 12 volts. And VC is 7 volts. So that is it. That is all that I have for this slide lecture here. And hopefully it was helpful for you. Thank you for watching and have a nice day.